there, welcome to the new video. In this video, I am going to discuss the project which I have created for churn prediction, driver churn prediction. So let's see. So yeah, this is the problem statement. It is recruiting and retaining drivers is seen by industry watchers as a tough battle for our taxi booking company. Churn among drivers is high, and it's very easy drivers to stop and fly or jump to Uber depending on rates. Okay, so like there are many companies for taxi booking, and this is the you have to I have to work as a data scientist. So I'm working as a data scientist in one of these companies. So this what I have to do for the company is that I have to predict whether the driver is going to get churn or not. That means if the driver is going to leave the company or not. Okay. So if I can predict this, we would be able to retain the drivers. So use the strategy. Company can use strategies to retain the drivers which are going to churn. So it is going to save a lot of money for the company also because they can uh, spend money on drivers which are likely to um, churn and not for all the drivers. Okay, so I think that's good. You are working as a data scientist as with analytics department of this taxi booking company focused on driver team attrition. You are provided with monthly information for a segment of drivers 2019 and 2020 tasked to predict whether a driver will be leaving the company or not based on attributes like demographics, tenure information, historical data regarding performance. Okay. So this is the columns which we have in our data, which is that reporting date, this is driver ID, this is age, this is gender, city code of driver, okay, education level, is it 0, 10 plus, 0 for 10 plus, 1 for 12 plus, and 2 for graduate. So these are the values in education level. This is income, monthly average income of the driver. Okay. This is date of joining, last working date, joining designation. Okay. And this is grade of the driver at the time of reporting. Now here, and this is another column which is total business value. The business value acquired by the driver in a month. Okay. So this is, and this is another column, quarterly rating, which is the quarterly rating of the driver, which is given by the customers. Okay. So I think this is simple. Now here you might ask what is the target column. So there is no column with the name churn. Okay. So we will create this going forward, but we will use this last working date column. So if there is a date here in the last working date, then that means the driver has left. And if there is none, then that means the driver is still with us. So we are going to create this going forward. So we are getting our data. This is our data frame. As you can see, we have month, driver ID, age, etc., education level, date of joining, etc., etc. Okay, this is we are doing the describe to see the mean, standard deviation, and everything of that. Okay. So I think we can see this values. This is good. And this is df.info. We are seeing the columns and the non-null count there. Okay. So total we have 19104 rows. Okay. And here there are some missing values. As you can see here, there are some missing values. Otherwise, in other columns there are no missing values. Okay. So you can see missing null values is here last working date. It has 17,488 null values. Okay. So, and 61 in age and in gender 52. Okay. So we will first drop our unnamed zero, which is just index. This is not useful for us. Let me show you. This column is not useful for us, so I'm dropping it. Okay. I have dropped it. Now we are converting the month and date of joining and last working day feature to date of time. Okay, to date time. And then we will be able to access the month, the date, by using the pandas function, Python functions, right? So for that, we have to create it first to the datetime object. Okay. So this is datetime object, datetime object. This is the int float, education level is object. Okay. So this is just basic. Now let's create separate data frame numerical columns only. So here I am creating a separate column for numerical columns only. Okay, and we are storing it in df underscore num. Okay, the driver ID is of no use when we are doing KNN, so let's drop it. Okay, so this is we are going to do KNN imputation for our missing values. Okay, now for that driver value will not be useful for us. Okay, so we are going to dropping it. So for KNN, because we are doing KNN, we are just having our numerical columns and storing it in df underscore num, and then we are dropping driver ID because it is not useful for us. Okay. Yeah. So I think this is good. Now let's see. We have age and gender. These two numerical columns has missing values 61 and 52. Now we want to fill this using KNN. Okay. So what we are doing is to see just gender. Gender has this many zeros and this many one values. Okay. This is we are going df num columns to list. Okay. So this here we have just taken the names of all the columns and we created a list, and then we have stored that list in num columns. Okay. So this is for that. Now we are doing KNN imputation. We are importing KNN imputer. Then we are using it, and we are considering number of neighbors equal to 5. Okay. And weights are uniform, metric, and Euclidean. Okay. We are fitting it on our data frame, and we are transforming the data set. Okay. Now this is converting again into the data frame, and where columns is the name of columns we have already stored. Okay. So I think this is our data frame. So as you can see, we have the same data frame in the data frame format as it is. Let me just connect charger. Okay. Now let me just check if our video is recording or not. Yes, it is. Okay, so let's continue. This is our data frame, and as you can see, we have 0. Just let me zoom. Why isn't it zooming? I zoom it from here. Maybe. Where is the setting? Okay. Okay, I think this is good. Now you can see there are 0 values here. Okay, so we have filled our none values in both the columns using KNN. Okay, so okay. Now this is if we have gender also here, right? So our gender value after we did the KNN, you can see our gender value has some points because we did KNN. Okay, and KNN is in numerical columns. KNN takes the average of all the like neighbors, and it gives the value. So 0.6 means that there were like if there is 0.6, then that means there are 1 which was in majority and 0 which was in minority. Okay, so if 5 neighbors, there are 5 neighbors, then if let's say 3 are 1 and 2 is 0, then if you take the average, it will turn out to be 0.6. Okay, so that means we are just replacing it here. As you can see, if there is 0.6, then we know that majority class, which was the neighbors, was 1. So we are giving it 1. And if it's 0.8, then also it is 1 because there were 4 ones and 1 0 in the neighbor. So that means the average came out to be 0.8. So we are replacing it 1. And if it is 0.4 and 0.2, that means that 0 was more in neighbors and class 1 was less. So we are giving 0 as the value. Okay, we are replacing it. And now you can see Xander has this 1100 and this value. Okay, 0 and 1, two values. Now let's get the remaining columns. Okay, so we are taking the remaining columns from df.columns, and we are taking the values which are not there in num columns that we have stored previously. Okay? And this is the remaining columns. You can see I have it in a list here. Now we are concatenating it, and this is our df2, that is 19,104 rows and 13 columns. Okay? So as you can see, we have all the columns here. Okay. Now we want to create new features. Okay. Which will help our model. Okay. For that, we have to first do the aggregation. Okay, for each driver. So there are multiple entries of one driver because it is reporting multiple times, right? So the entries of one driver ID will be multiple. So you can see driver ID month. So I have grouped by driver ID and month, and we are aggregating it. Okay? So this is driver ID 1. You can see this is the month, age, gender, city. So you can see there are multiple values. Let me show you. Okay. So yeah, this is showing this in last working date. You can see N80, and this is right total business value quarterly rating. Okay, so you can see there are multiple total business values. So when it reports every month, so you can see 2019 11, 2019 22. So every month the driver will report, and this is the business value which they have for that month. Okay, and this is the quarterly rating. You can see. So we have sorted this, and now we get this. We have sorted using true sort index. So we have sorted the based on the index, okay, and in ascending order. So that is that true. Okay. Now for both we have sorted driver ID and month both in ascending order. So there are two trues here. Okay. So this is our that, and we are resetting the index. Okay. And now we want to create new features. Okay, for that, what is the feature we are creating? So let me just flip this for a moment. Let me explain you the this feature first that we have created. Okay, where is it? Okay, yeah, so we are creating a new feature which is income increase. Okay, so we want to check if the driver has increased his income, the business value. Okay, from the first month, which is of his reporting, to the last month. Okay, so we are going to subtract that if the business value of first month, the income of first month, and the income of last month of the reporting of the driver. And if it is negative, that means if I mean if it is positive, that means the income has increased of the driver, and we assign one to that. Okay, as the value of this feature, and it is 0 if it's the same, if it's equal, and it will be -1 if the first month income is greater than the last month reported income. If it is if the first is greater, last is lower, that means we will give -1 as the value. Okay, to this income increase because the income has decreased and it is not increased. So we are giving -1. So this is just we have created the group by, okay, with driver ID, and we are just doing group by income if the I log 0 means the first value and I log -1 means the last value, okay, of the income of that group. Okay, so if it is this is greater 1, otherwise 0, otherwise -1. This is simple. Okay. Now we are converting it into dictionary to a data frame. Okay. And as you can see, this is our data frame. Income increase DF. Driver ID, income increase. For each driver, we have uh, the value of income increase, whether it is increased or decreased. So let's see this income increase value counts. So there most of the people have the same income. Okay, 2338, and only 43 drivers have their income increased, and none of the drivers has their income decreased. Okay, so yeah, it's good. Now let's create a new feature, grade increase. So now so this is the feature. Okay, now let's say if my driver has an income in first month as 2 rupees and in the last month as 5 rupees. But in the middle months, which I'm not accounting for, they have -2 or like very low, then that means -2 or -5 or big negative losses like that. In that case, I will not be able to capture the loss of the driver in this income increase feature. So I have created a new feature, which is this feature. Where is it? Let me show you. Okay, this is good. Yeah, here I have created a new feature which is sum of difference business value. Okay, so first for that we have to first create the difference of business value. What is the difference of business value? So let's say if this is the total business value, okay, in that I will minus the first value with second and I will put it here as a difference of business value. Okay, so you can see first one is 0 and second one is this value. So this value came when I negated this value minus this value. So I am doing second value this minus the previous value first and I got this value. Okay, so similarly the will be third value minus this second value will give me this value. Okay, so I am doing it row wise, second row minus first, third row minus second. So this difference I am showing it in difference in business value. Okay, which is the difference from last reporting month to the current reporting month. Okay, and now I am doing the cumulative sum of all these different business values. Okay, so if there is an increase or decrease, all these I have to sum and then I will get a cumulative value, which will be our sum of difference business value. Okay, so I think this is fair, and I have created this cum sum of difference of business value. Yeah, so this is our new feature. Let me show you. So if you can see, this is 0. Now this is this. Now you can see I am just doing the cumulative sum. So it's this plus this equal to this. Now this plus this equal to this, and then we are adding zeros. This is 0. Okay, so no difference here, and then we are adding this. So this is the value. Our value got increased, and at the last we get this. Okay, so sorry, this might be of different drivers. This is for one. For one, we have only three values. Okay, so this, and this. Okay, so for driver one, this will be our last value, cumulative sum of all this difference business value. The cumulative sum of this three values is this. Okay, so I think this is clear. Now let's just, and then we are dropping the difference business value because it was just created to create our sum of difference business value feature. We are dropping this now, and this is income increase. Similarly, like we created income increase, we will check if our driver has increased the grade or not. Okay, so for that, if the first grade, the grade of the first reporting month is less than the last, that means there was increase in grade. So we are giving 1 as the input, as the value of grade increase column. And if it's same, we give 0. If it's decreased, we give -1. Okay. So you can see there were no -1, but only 0 and 1. So most of the drivers had their grade same. So let me check if the recording is still on. Yes. Okay. Good. Now we are going to aggregate values for each driver. Okay. So that is what we have done here. Let's move. Yeah. Now we have created a new column again, which is the rating increase. Similar like grade increase and income increase. Rating increase means that what do we call it? Rating increase means if our rating of our driver on the first reporting month is lower than the last reporting. That means there is increase in the rating. So we will give 1. If it's same, we will give 0. If it has decreased, we'll give -1. Okay. So yeah. So you can see there were some decrease in ratings for some drivers and fewer drivers than that had their rating increased, and most of the drivers had their rating similar. Okay. Now let's add rating. Okay, this is we have added. We are adding all these columns which we have created to our uh, DF2 ADG, which is our main data frame. Okay, so I think this is clear. Okay, now we can see our last working date as main values 765. Okay, we are creating a new feature churn, which will be our target feature based on this. So if the last working day is if it is none pd.isInit, then we are giving 0. Or else if there is a value, then we are giving 1. So this is for churn. Sorry, this is not churn. 0 means the driver is still there and it has not churned, and 1 means the driver has churned. Okay, and we are dropping this columns which are not useful for us. We are just getting the month, date of joining, dt.month. So we'll get month and we are storing it in joining month, and we are removing the rest of the columns, date of joining, last working date, driver ID. Okay, because we have done the aggregation and the feature creation. So now we do not need a driver ID column. We are just removing it. Okay. Okay, so here we'll start our analysis visualization. First, we have done the univariate analysis. You can see this is for age, ADE for age. Let me just zoom out a bit. Okay, this is better. This is histogram KDE of age. You can see it's like a Gaussian. This is like a Gaussian with a big tail on right side. Okay, for income. This is for business value. It has outliers. We have not removed any values from total business value. So that means it is like this skewed, not properly visible, this graph. Similarly, for this sum of difference business value, it also has outliers, huge range of values. So it is showing like this. Okay. Now we'll do the visualization for categorical columns. So this is for categorical columns. As you can see, education level, uh, it's similar 0, 1, and 2. Same amount of drivers for all three classes of education. Bar plot of joining designation is this. You can see joining designation for 5 is the lowest, and joining designation of 1 is the highest. Okay. For our grade, we have 5 as lowest and 2 as highest. So majority of our drivers have 2 as his grade. Quarterly rating, you can see majority of them 1, and very less people drivers have 4 as their quarterly rating. Okay. This is the joining month. You can see most of them have joined after in between 5 to 12. In 1 to 4, there are very less people, very less drivers that has joined between 1 to 4 months. Okay. This is income increase. You can see majority of them has same income, no increase, and some driver has increase. Similarly for rating increase, okay, -1, 1, and 0 are in majority. Means rating of majority drivers is same. For grade increase, majority of them are in 0 and some of them are in 1, which means grade has increased. Bar plot of gender. This is for gender. Majority 0 and 1. bar plot of city. You can see this is like majority of them are from, if you may, what is this called? C13, C9, C11, C2, C1, C26. No, C20, I think. Yeah, I have written in insights. I'll just check. So yeah, this is the insight which we have from our set field. Okay. So as you can see, C20 has highest number of occurrences data. C11 has the least occurrence data. 32.1% of drivers in our data set has remained and rest all have joined. Okay. One is for churn and zero is for remain. Yeah, so this is true. Now 19.2% of drivers has decrease in rating and 15% of driver had increase in rating. For rest of the drivers, rating remains same. Only 1.80% of drivers income has increased. For rest, it has remained same. Okay. So these are some insights as you can see. Now let's go to our EDA for bivariate analysis. First, let us check if your recording is still going on. Yes, this is for bivariate analysis. Now you can see I have plotted for our churn versus age. Okay, so you can see for drivers who have not churned zero have a slightly higher median of age, and those who are a little bit less median of age. Okay, but this visually it is not clear. Okay, so we are going to do hypothesis testing going forward. But first, just have a look at the graphs. For this, it is clearly visible that income of drivers who have not churned is a bit higher, at least the median, okay, 50 percentile, this line. And for drivers who have churned, it is a little less, income is little less. So, yeah, and you can see there is a massive difference in total business value of driver who has not churned versus those who have churned. So these features, this income and this total business value is like important for us to for our model. Okay. So there's some of difference business value. You can see there is some difference there. We are going to do hypothesis testing also. So first, okay, now this is like create a bar plot. Okay, now this is for our categorical features. You can see the education level for both the classes. So this is the categorical feature with our target feature. We have done the bivariate analysis here. Okay, so you can see that driver who have not joined has like there is like equal proportions in both join and not join for the education level. Okay? So I think education level does not make a big difference. So we might remove it in future after hypothesis testing if it's not relevant. Okay, this join designation, you can see there is like not much difference. Okay, for this, if the grades are 4 and 5, I think the count of those who are churning and not churning is equal. Otherwise, the churning possibility is very high compared to not churning if the grade is 1, 2, or 3. Okay? So yeah, this is the like insights for that. If the income increase is there, then our driver is more likely to not churn. Okay, so this is also a good predictor for our model. This income increase column. Okay? For rating increase, if it is 1, if our rating has increased of a driver, then he is more likely to not churn, 0, and less likely to churn. In the other cases like -1 or 0, it is the driver is more likely to churn. So these are the insights. Same goes for grade increase also, you can see. And this is for gender. For gender also, like there is not much difference. Like gender does not show a difference whether based on that it will churn or not churn. Okay. So yeah, this is for city and this is for churn. So one has more instances in our data compared to zero. Okay, so this we have already seen. So these are the insight. For each joining designation, probability of churn is higher, obviously. For grade 1, 2, and 3, probability of churn is higher. For 4, 5, probability of churn versus non-churn is almost equal. This we have already discussed, okay? All this same, this is insights. Now we are going to do hypothesis testing because we saw that for our gender, for our education level, some columns, there were not a much of difference. So if we are going to validate it with hypothesis testing. Okay. So yeah, we are going to first do hypothesis testing for all our numerical columns. Okay, and we are going to use t-test for that. Okay, and you can see that t-test end we are going to say churn yes, churn no. Okay, if it has churned or not churned, we are going to store separate it as a data frame, and then we are going to pass the values in our t-test, and we are going to see the p-value. Okay, so the p-value for age is 7 point something 10 raised to minus 5, which is obviously less than our significance level, which is 0.05. So this is a relevant feature age for us. Income same. Total business value 10 raised to power minus 45. So very relevant for us. So we are going to keep this. We are also going to keep the sum of difference business value. All four values are to be kept because they are useful. We have also done veterinary test. Okay, why is this? Because this is a non-parametric test. So there are assumptions for our t-test which requires to follow kind of normal distribution, right? And as we previously saw in our visualization, some of the numerical features does not have normal distribution. Some is skewed, some different. Okay, so for that, I have also used this test, which is non-parametric test, man-Whitney U test for our numerical features also, and they give similar results. Okay, all four columns has p-value less than 0.05. Okay, that means that we have to keep this columns. Okay, these are relevant for us. Okay, we have to column. Okay, now we have to do the hypothesis testing for our categorical columns. So our target column and our categorical columns. So both of them are categorical in nature. Okay, so if we are doing hypothesis testing between two categorical features, then we have to use tie2 test. Okay, so for that chi-square test, sorry, my bad. And we are using this function tie2 contingency. Okay, and we are passing them, and we can see that our education level is 0.46, the p-value. That means it is greater than 0.05. So this means we cannot reject the null hypothesis. And null hypothesis means that education level has no effect on our target variable. So our visualization that we saw for education level is been further proved here that education level does not affect our target feature. So we are going to remove this, and other all the other values are less than 0.05, but this value for gender, it is also greater than 0.05. That means gender also does not affect our target feature. So we are also going to remove gender from our data. So yeah, we are removing this, as you can see both the columns. Now we want to see some correlations. Okay, so why I have used Spearman? Because see, in some of our numerical features there are um, outliers, right? So if you plot it, the values will be in some range, then it will grow exponentially. So there are exponential that thing nature of values. For that, Spearman correlation is useful because Pearson captures the actual values. It does the actual, so the exponential will be problem. But Spearman gives ranks first. So if the first value is like 100, second is 90, like second is like 90, and based on that, based on actual value, it will give 1, 2, 3, 4 such kind of ranks. Okay, so if let's say one value is 100 and the another big value is 1000, then the exponential jump will be removed because we are giving Spearman will give rank, let's say 10 to the 91, and for 9000 it will give 11 rank because it's greater than this. Yes, so from 90 to 9000, Spearman gives rank 10 to 11. So that is that exponential thing is cut out, which will help us capture our correlation better. So we have used Spearman correlation, which is a rank based correlation. Okay, as you can see, these are the things. Where is it high? Let's see the insights. Okay, so we can see there are not much correlations now. Okay, so we are not going to remove any of the columns based on because they are correlated with some another column of our data, right? So let's move forward. Okay. Okay. So now we are ready to train our model. Okay. So first we have to do some normalization, and we have to also convert some of our categorical column values into numbers because our model only understand numbers, not words or strings. So we are going to do encoding for that. Okay. So first we want to normalize our numerical features. So this is the list that I have created features to normalize, and then we are first doing the split, train, validation, and test. Okay, train and test 80-20 split. And from the train test, we are again taking 20 percentage and converting it to validation check. And rest is the training, which you can see here. Okay. So we have train, test, train, validation, and test. Okay. Now we are going to do mean encoding of city. Okay, city is our feature, categorical feature. Like C1, C2, C23, such type of values are there. We want to convert it into numbers. So how we will do that? We will do it based on the churn. Okay, the churn feature, which is our target feature. Okay, so we are going to take the mean, okay, for each city. So we are going to group by each city, and we are going to take the mean of values of churn for that group, and we are going to store it in mean encoded city. For each city, there will be an average of the mean, means the mean of the churn values for that group. Okay. So for each city, there will be a value, okay, which will be the average of the churn of that group for that city. Okay. So this is train df.map, and we are just now encoding it. Okay. Train df city, well df city, and test df. So what we did here was we first split because if we would do this encoding on the whole data set, then there will be data leakage because we are also getting our encodings from the test part of our data. Okay, so first we separated both train, validation, test. Then only from train we have taken the encodings, and then we are using that encodings for our validation and test also. Okay, to convert the feature values of validation and test also into numbers. Okay, which will not cause data leakage. So I think this is clear. We are just separating here, separating feature and target variable. This is simple. Min max scalar we are using, and we are doing fit transform on XTrain and transform on val and test. So yeah, I think this is clear. And we have our data, as you can see, 11 columns, 1, 5, 2, 3 rows, and all of them converted into numbers. Min-max scaler will convert all the numbers between 0 to 1. Okay. So yeah. Okay. This is validation. This is test. Okay. 477 rows and 11 columns in test. 381 rows and 11 columns in validation. Uh, Now we are going to contact our xtrain and xval, ytrain and yval, and create it as a training set. Okay. For training our models. Okay, so first model that we are going to use is Randomforest. So we are going to try ensemble methods. First, we are going to try Randomforest. This is training and hyperparameter tuning. So let's see. We are in class weights. Okay, so as you know, our data is unbalanced. Okay, so we are giving more weight to our zero class because it is minority, and one for one class we are giving one as a weight. Okay. So because and so if you see it will balance out on both the classes because zero class is almost half of that of number of one class instances in our data. So I have given two as a weight to zero class and one as a weight to one class to balance out. So you can see we are going to use Bayesian search, which is better than random search CV and grid search CV. Okay. So we are going to use Bayesian search, which will take the range of the parameters. So we are giving for estimator 10 to 500. For depth, we are giving 3 to 45. For sample split, 2 to 10. Okay. Sample leaf, 1 to 10. Okay. So these are the range of parameters which I have provided, which it will try. And then it will find the best hyperparameters based on the scoring which we have used this ROC AUC. Okay. So yeah, this is um, we have used Bayesian search CV. We have used Randomforest with class weights. Okay, and this is we are fitting our X to Y tree, and we are printing our best parameters. So this is our best hyperparameters. You can see that max depth 10, mean samples 1, mean sample split 10, number of estimator 339. Okay. Now we are using these parameters and we are getting the predictions on our test. So let's see. So you can see I have stored our best random forest model in best underscore RF, and I'm using fit to train my it to train it on my training set. Okay, X train and Y train. And then I'm using it to predict on my X test. So I think this is fair enough. And then we are just using precision score equals for functions like that, giving it y test and y pred, and we are getting the performance matrix values. Okay, and we are printing our ROC AUC also. Okay, so you can see this is our ROC AUC curve with AUC 0.93. Okay, so this is good, and this is our confusion matrix, which you can see with I also printed the classification report, which will give us the precision recall F1, etc., etc., etc. So yeah, so for zero class precision is 80, recall is 86, F1 is 83, for 193, 90, and 91. So for our minority class, you can see that precision recall is still not that good compared to that of class 1. Okay? And you can see 22 and 33. So total 55 of value is misclassified. Okay? Out of 477. And this is for feature importances. So in trees, we calculate feature importances based on how many types that particular feature has occurred in splits while splitting. Okay. So based on that, we calculate feature importances. These are the values. Most important feature is sum of difference business value, which we have created. Okay, so that feature we created is useful for this model, most useful. And the least was income increase. Okay? Important, least important. Conclusion of results. AUCRO 0.93, F1 score of class 0, 8.83 for majority class, 0.8, sorry, 0.91, 55 of misclassified out of 477 test data point. Uh, yeah, sorry, my voice just. Okay, this is balanced random forest. So let me show you. Because our data is misbalanced, like on imbalance, we are going to use this version of random forest classifier, which is balanced random forest classifier. What it does is, you can see this is the documentation. It will draw a bootstrap sample from minority class and sample with replacement the same number of samples from majority class. So it is doing undersampling. So let's say there are 10 instances of our minority class, 90 of majority class. Then it will take 10 instances from majority class and then 10 instances from minority class, and then it will train. So this is an undersampling method. So we are using that model. Same things, parameters, Bayesian search CV we are using for hyperparameter tuning. And this is just that the train that we are giving. It will split it into four parts, and one part will be validation, which will be used to find the best parameters. Okay, so it will train on three parts, then it will check the ROC AUC on the fourth part, and it will compare for all the hyperparameters, and whichever hyperparameter is giving good ROC AUC score, then it will give those hyperparameters to us. Okay. So yeah, as you can see, these are the best hyperparameters for us. 0.94 for 1, 0.74 precision for class 0, which is not that good. You can see 47 and 17. That means 50 and 64 of misclassified instances out of 477 of our test data. ROC same, AUC 0.93. Feature importance is same, sum of difference value, most important. Income increase, least important. So these are the conclusions. You can see this. Now we are going to use another model, which is XGBoost Classifier. So we are again giving class weights, okay, for because our data is imbalanced. It has more features, as you can see, more hyperparameters, learning rate, number of estimators, means number of learners, max depth, mean child weight, subsample gamma, whole sample battery. These are the hyperparameters. And yeah, so all the same things, and you can see precision is 0.77, equal is this, F1 is 0.81, 0.93, F1 score for 1 is 0.90, and 62 misclassified points out of 477. So it's performance similar like previous model, right? So not much difference. So yeah, here feature importances are different. Business value, total business value is the most important feature. Income is second, which was last important in our previous models, but in this one, it's like second most important. Rating increase is the least important feature in this model, XG boost classifier. Okay, so yeah, this is the conclusions. AUCR 0.93, etc., etc. Okay, now we are going to use LightGBM model. Same things, hyperparameters, Bayesian search CV we are using with number of splits 4, and we are getting the classification report, which is 0.81 and 0.90. Similar performance like previous models. Okay. ROC AUC again 0.93. Most important feature total business value, sum of difference business value, and the least is incoming trades. And interestingly, it has 30 and 58 plus 3, so it has 61 misclassified points. So yes, performance similar to previous model, this one also. Now we are going to use RUSBoost. Okay, so let me show you what is RUSBoost. This is for imbalanced data. Okay, so random undersampling integrated in learning of AdaBoost. Okay, so it will do undersampling and it will use AdaBoost. Okay, so by combining these two, RUSBoost has been created. We are using that. Okay, hyperparameters are, as you can see, all the rest all is same. Bayesian search CV, number of splits 4 with stratified k-fold. And by the way, stratified k-fold is for imbalanced data set. So when it is doing the splitting, right, it is making sure that all the 4 splits has equal number of classes, percentage of both classes. Okay. So let's say in first split there are 80% minority class. Sorry, 80% majority, 20% minority. Then in the another split, the second part out of 4 parts, the second part also has the same proportion of both the classes, 80 and 20. So it is making sure that so it is stratified k-fold and not just k-fold. Okay, so this is clear. Okay, now yeah, this is interesting because here you can see our F1 score, and for both the classes is slightly higher than another previous model we have used. And our misclassified instances is 31 and 20, which means that 51 only, okay, which is lower than the previous ones. And the most important feature is sum of difference business value, which we have created. Least is incoming bits. Fair? Okay. This has the lowest number of misclassified points for the model, which comparing to the model which we have previously tried. Okay. Now, we are going to try a different approach. First, we are going to resample the data based on SMOTE, which is an oversampling method. So what it will do is, let's say our minority class is 10 and majority is 90. Then by taking this 10 data points, it is going to create 80 other synthetic data for our minority class based on this 10. And so after that, our total will be 90 and 90. So this is an oversampling of minority class. So this is called oversampling method. We have done that. You can see now the classes are equal 1292 and 1292 for 1 and 0 class. Now we are going to use Randomforest classifier without class weights. First we have tried class weights in our previous that we have tried. Here I have already balanced the data set. And now I am using the simple vanilla Randomforest classifier. Okay. All the things, same things, just number of splits. I have created 5 because now our data set has increased. So 4 parts for training and 1 part for validation. Okay. Now these are the same things. You can see 0.93 AUC. You can see 83 and 91, and misclassified point as 55, which is closer to our first previous model, RUSBoost, that we tried, but RUSBoost had 51. So RUSBoost is still better than this one. Okay. Okay. Now what we are trying XGBoost Classifier. Okay. Same things. We are seeing 0.82, 0.91. Misclassified points 31, 25 means 56 in total. Similar to the Randomforest we tried, not much difference. So yeah, same things. Now we also want to try LightGBM. on resample data. So I have done all the same things. As you can see, the AUC is a little lower than the previous ones, 0.93. Okay. So what was previously? Let me check. Yeah, 0.93. All the previous model had 0.93, but this is 0.92. So this is bad compared to all the previous models. So you can see misclassified noise is 56. Okay, yeah. And this is now conclusion, final conclusion. So best model we got was RUSBoost, which performed the best. Okay, and it had the lowest number of misclassified point, which was 51 out of 477. And the F1 score for minority class was 0.84, and for majority class it was 0.92, okay, which is good. So, and sum of difference business value is most important feature. Okay, and these are the best hyperparameters for our model. So we have trained a model successfully, and we are going to integrate this model in our company, which will help us determine whether a particular driver is going to leave or not. If the driver is going to leave, then we have to give him more incentives to stay. Like we can decrease the percentage of the company can decrease the percentage of cut or the commission which it takes from the driver. And other thing which the company can do is also provide some health benefits like insurance, etc., more employee benefits to that particular driver. Okay, and the company can also give this driver more frequent customers. So this driver needs to have some kind of priority compared to other drivers so that he can find customers easily compared to other drivers. So this will make him more likely to stay. Okay? So yeah, this recommendations I have given, and another recommendation which can also be given to the company is that company should work closely with drivers whose total business value is not increasing, okay, or decreasing, because we have seen that feature, the sum of difference business value, that feature is the most important according to our model. So it is created from this total business value feature. So we have to check if it's not increasing, and if it is decreasing, then that driver is more likely to leave the company. So if our team notices this, then we have to give more incentives to that driver, or we have to figure out why this driver is not getting the more total business value. Company should do analysis of reviews of users and inform the driver about why their ratings are not increasing or why it is decreasing. Okay. This should help the driver make necessary changes which will help the grade, rating, and income increase. Okay. So yeah, so these are the recommendations for our to stop the churn. Okay. So yeah, thank you for the video and see you in another one. Bye.